Okay, so yes, we've seen the first two, 1 and 2. Now, here we saw that the only thing that goes is this R prime, right? And you put the positive guy. Now, on 3, and I want you to know that this reaction is called saponification. You don't have to try and remember it. This is where you break an ester using a base. Okay, here we break it using water. Now, on 3 and 4, look at what happens. On 3, they call it ammonolysis. It is just where we are now making an amide. Okay, we are now making an amide, and we know what an amide is from our functional group video. It is when you have, remember, you have a nitrogen, but then you're going to have a carbon. So it's like, let me put it like this. It's a carbon with a double bond O, then bonded to a nitrogen, which then does whatever it wants. Okay, could be hydrogens or whatever, but there's a double bond O and there's a nitrogen. So that's an amide. So basically, what are we going to have? We have an ester. Let's put our ester. It's going to be C double bond O bonded to R. Then here it is bonded to O, then R prime. Okay. So what happens is it's going to meet ammonia, NH3. Now, when it meets ammonia, look at what happens for the next two. For ammonia, it's going to cut this off. Okay. Because we need the double bond and we need the N. So it's going to cut this off. So basically, we know that always we get R prime OH. Okay. But this time the R is actually going to go with these all together. Boom. And we are going to remain with C double bond O bonded to an R, then bonded to an N. Okay. That's what you're going to have. It's C double bond O, then bonded to an N. But this N, you can have it as an NH2 because nitrogen needs 3 bonds. So here's what you're going to have. And this is going to be what happens. So basically what we know is one of the H's goes with this RO, becomes ROH, and then the other two come here. So that is for ammonolysis. Okay, that's for ammonolysis. Never forget what happens. Okay, and this is your amide. Okay, we call this the amide, and you're done. Now, for the fourth one and final one, it is what happens when you are going to add, when you're going to do the reduction. And we've talked about this. So here in reduction of esters, we know that, ooh, crazy stuff. What do we use? LiAlH4. Okay, what do we put it in? Let's put our ester. Okay, C double bond O bonded here to an R, then here bonded to an O, then R. Okay, so we can call it R prime O, like we've been doing. Okay, or we can say it is O then R prime, doesn't matter. Okay, did we say O then R prime? Yeah. Then what do? We make it be reduced. LiAlH4. Remember, this thing should be in ether, and we make it a little bit acidic. So H3O plus. Then what are we going to get? What are we going to get? Here what happens is, remember, boom, go away. So we're going to have an R prime OH, yes. And then what about here? We get an R, okay, let's start with the C. C is now single bonded to the OH, okay? And then what happens here? We are bonded to the R, okay? And then what happens here is that this carbon gets 2 other hydrogens. We can write it as CH2, and that's what happens. So this double bond O becomes a single bond OH, okay? This whole thing goes to become R prime OH, and then we put 2 more hydrogens, okay? Because one was from the double bond, which we've made a single bond, and the other one was from the bond with this R prime O, okay, which goes. So basically, never forget that for esters, we always get that R prime OH. This guy that was bonded to oxygen going to make an alcohol every time. But in these last two, remember that it is actually going together with these O, and then somebody else comes here. It is NH2 that comes here. It is the hydrogen that comes and he's 2 of them because he also breaks this double bond. But in NH2, this double bond is not broken. Okay, never forget that. And these are the reactions of your esters, and you are done.